Hey everyone, welcome back. In today's video, we'll be exploring the role of various types of variables when working with functions in C programming. We'll talk about local, global, external, static, and register variables, while focusing on their behavior in functions, including their scope, initialization, and their default values. So let's dive in. The first type of variables we'll be seeing are local variables or automatic variables. Now, local variables are those variables that are declared inside a function and are only accessible within that function. They have a limited scope, meaning that they cannot be accessed outside the function in which they are defined. Let's see this with the help of an example. So I will define a function here, and inside this function I will declare a variable. And let's print the value of this variable. Okay, now let's call this function. Okay, now let's try to understand this code. In this code, as you can see here, I have declared a variable inside this function. Now, since I've declared this variable inside the function, this variable becomes a local variable. Now, what I mean by a local variable is that this variable can only be accessed inside this particular function. It cannot be accessed elsewhere. So let's try to run this program first. Once I run it, I will execute this function and print the value 10. But what happens if I try to directly print this value of this variable inside another function? Let's go ahead and try this. As you can see, my compiler gives an error. The error is that the variable var is undefined. Now this is because local variables cannot be accessed outside the function in which it is defined. That is, the scope of a local variable is limited to the function in which it is defined. Now let us see the properties of local variables. Now when I talk about properties, we'll be talking about three things: the scope, the initialization, and the lifetime. Let's begin with the scope. Now when I talk about scope, I mean that where can the variable be accessed? Local variables can only be accessed in the function in which they are defined. In this case, the scope of a local variable is limited to the function. Thus, it is local to the function. Now, initialization. Initialization means that, let's say we do not initialize the value of a local variable. So if we do not initialize, what value will a local variable take? In case of local variables, they take garbage values. So if you do not explicitly specify or initialize the value of a local variable, they will hold some kind of garbage value. Let's see this with the help of an example. Let's say I do not define the value of var, and I just print it here. Now what will happen in this case is, if I go ahead and compile and print it, we will get a garbage value. Just give me a second, I forgot to call this function. So let's call it here and let's run the program again. As you can see, I have got some garbage value. This is what happens when we do not initialize local variables. So it is a good practice to always initialize local variables before we use them. Now what is the lifetime of a local variable? Now lifetime means how long will a local variable exist, okay, in a function or in a program. In case of local variables, local variables only exist during the function call and they are destroyed after the function completes. That is, space will be allocated when the function is called and it will be released when the function terminates or completes the execution. This is known as the lifetime of a local variable. Now this makes local variable ideal for temporary storage specific to a function without affecting the rest of the program. Now let's come to the second type of variables, which are global variables. Now global variables are those variables which are declared outside to any function and are accessible from any function within the same file or program. Now this allows different functions to share and modify the same variable, which can be convenient, but it requires caution to prevent unintended changes. Let's see this too with the help of an example. So I'll take a function here, and before the function I will declare or define a variable. Let's say var int var is equal to 5. Now this will take the value of 5, and what will my function do here? My function will increment this value. Okay, it will increment the value by 5. Sorry, yeah, this is proper. Now let's go ahead and call this function. What we'll do here is, let us define two functions that use the global variable. So let's define another function. Now this second function, what it will do is, it will just print the value of the global variable. Okay, so what we'll do first is, let's call function 2 first, the second function. Then we'll call function 1, which will increment the value. And then again we'll call function 2. Now once we execute this program, as you can see, we got the value 5 and 10. The value 5 comes from the second function which we called at the beginning of the main function. Then what happens is, the value gets incremented by 5, and then again after calling on the second function, we get the value 10. That is the updated or incremented value of the global variable. Now the main difference between global variable and local variable is that every time a local variable or a function is called, the variables inside a function are reinitialized. It means that they will again take the value which we have given them inside a local variable. But in case of global variables, the values will not be reset. Okay, the values will just be modified every time we make some changes to that global variable in a function. Now let's talk about the scope, the initialization, and the lifetime of global variables. Now, when it comes to global variables, they can be accessed from any other function within the same file. They can also be accessed by functions inside other files. But in order to do that, we need to use a special keyword which we'll be seeing in the next variable, the next type of variable. Okay, so in order to access global variables in the same file, we can simply use that variable in any function which we will be calling. Now coming to initialization. Now by default, global variables are initialized to 0 if we do not give it any value. Okay, so if we are not giving global variables any value or not initializing them, it will by default take values of 0. For example, if I do not define the value, if I do not initialize the value of var here, it will take the value 0. So let's go ahead, compile and run this. You can see it took the value 0, and after calling the function, it incremented the value to 5. So this is about initialization of global variables. Now let's come to the lifetime. How long does a global variable exist? Now global variables exist for the entire duration of the program. That is from the point where it is defined right till the program terminates. So this is about the lifetime of global variables. Now one thing to remember here is that while convenient, using too many global variables can make debugging of code harder, as any function could potentially change their values. Therefore, it is best to use them sparingly. Now let's come to the next type, which are external variables. Now external variables are basically global variables only that can be accessed across multiple files. So if I defined a global variable in one file, how can I access that global variable in another file? It's very simple. I just need to use the keyword extern. By using the extern keyword, I can access a global variable in other files. Let's see this with an example. So here I made another file, and in this file I will declare a global variable. Okay, now let's try to access this global variable in another file. So let's see how we can access it. Now in order to access a global variable in another file, I will use the extern keyword. So I will mention it as extern int shared var. Okay, so here what I have done is I have referenced this variable which is in another file. Now let's go ahead and try to print this. Okay. So in order to for this to work, we need to make sure that both the files are compiled together. So what I will do is I'll have to mention both the files when I'm compiling them. Let's go ahead and run this. So as you can see, I can access this variable which is stored in another file. So this is how I can do it. Now let us look at the scope, the initialization and the lifetime of external variables. Now the scope of external variables is across multiple files if the extern keyword is used. Initialization. The initialized value in the original file is taken, otherwise it takes a default value of 0. And the lifetime of external variables is for the entire duration of the program. Now one key point to remember here is that this approach allows functions in different files to share the same variable without needing to pass it as an argument repeatedly, helping maintain consistency across files. Now coming to the next type of variables, which are static variables. Now static variables are declared within a function to retain their values between different function calls. Now this can be really useful if you want a function to keep track of its state between function calls without relying on global variables. Let's see this too with the help of an example. So what we'll do here is I will declare a function void count calls. Okay, after defining this function, what I will do is I will declare a variable. Okay, int call count. Now what will this variable do is this variable will keep a track of how many times the function has been called, and every time the function is called it should increment the value. Now here I haven't used static variables yet, so let's see what will we get each time we call the function. So let's call this function 3 times. So if I'm calling it 3 times, the counter should give me the value of 3 after 3 calls are made. Well, let's see whether it actually works. Okay, in this case what happens is each time I call the function, you see what is happening is this variable gets reinitialized. Every time I call the function, this variable again takes the value of 0. And as you can see, after even calling the function 3 times, it is telling me the function is called 1 time. So what I can do here, this variable which I've defined here, I can make it static. So by making it static, what will happen here is it will retain the value between each function call. So again, if I compile and run this program, you can see here, the function has been called 3 times. So this is what static variables do. Now let us see the scope, initialization and lifetime of static variables. Now the scope of a static variable is local to a function, but in this case it retains the value between function calls. Now what happens in the initialization phase? In case I do not explicitly initialize or give the value to a static variable, it will be automatically initialized to 0. Unlike local variables which take garbage values, static variables are initialized to 0. Speaking about the lifetime, static variables exist for the entire duration of the program. But one key point to remember here is that the scope is still limited to the function in which it is defined. The only difference here is that it retains the values between each function call. Now one key point here is that this approach is really helpful for counting calls or storing persistent data within a function while keeping the variable hidden from other parts of the program. This is when I can use static variables. Now let's come to the last type of variables, which are register variables. Now a register variable is stored in a CPU register instead of the RAM, making access to these variables much faster. Now in order to do this, we use the register keyword, which basically tells the compiler that I want to store this value in a register. Now it depends on the compiler whether to ignore it or actually store it on the register. Now this totally depends on the compiler, and we cannot force a variable to be stored on a register. Now let's see this with the help of an example on how we can define register variables. So what will I do here is I will just define a function, and inside this function I will define a register variable. Okay, so what will happen here is that my compiler will attempt, remember it will attempt, it will not guarantee me that it will store in a register, attempt to store in CPU register. And let's call this function here. Let's print the value. We'll compile. Sorry, just a second. Yeah, this is the correct function. And we'll run it. We got the value 10. Now this hasn't guaranteed that my value is actually being stored on the register or no. In order to check this out, I can either debug my program to find out whether the value is actually being stored on my register or not. So this is about register variables. Now let us look at the scope, the initialization and lifetime of register variables. Now same like local variables, register variables are also local to a function. One thing to remember about register variables is that they require to be explicitly initialized because they do not hold any default value. So anytime we are using register variables, we should make sure we have initialized them. And the lifetime of register variables only exists during the function call. Once the function terminates or the function executes, the register variable will be destroyed. Now, why and when to use register variables is basically when we want uh, to use them for some value that is frequently accessed within functions. Okay. Now let us have a look at the summary of all these variables which we have seen. So we have seen 5 types of variables: local, global, external, static and register variables. This is the scope of these variables. For local, it's within the function. For global is all functions in the program. For external is across multiple files. For static, it is within the function but it retains between calls. And for register variables, the scope is within the function. Now speaking about initialization, local variables required to be initialized. Global variables and static variables, it is optional. And external variables, it depends upon the file, whether we have initialized or not. But register variables have to be initialized. Now look at the default values. Local variables will give us garbage values if we have not initialized them. Global, external and static variables will give us 0 if they are uninitialized. And even register variables will give us some garbage value if we do not initialize them. So this is about the different types of variables and their use in functions. So that's all for today and we'll see you in the next video. Till then, take care and goodbye.